So in this video, we're going to be working about learning how to operate with scientific notation. Before we get started in adding, subtracting, and everything like that, we need to be able to manipulate scientific notation and change it from one power to another. So I've given you a little bit of example here. So I have 11.4 times 10 to the fifth power. This is not in scientific notation. The reason being is this factor is not between 1 and 10. So my job is to rewrite it in between 1 through 10. So in order for me to do that, I know I need to move my decimal this direction by one place. So that would give me 1.14 times 10 to the something power. But the question is, what power is it? Well, it's pretty easy if you look at it. If you kind of recall from the last video, when we're working with large numbers and we move to the left, we actually have a positive number. So this case, I actually jumped 1. So technically what I can do is I'm going to take that original 5 and I'm going to add 1 to it. All right, because I moved to the left here. Now, I know that's a little bit counterintuitive. That is probably one of the hardest parts about scientific notation, is because when I move the decimal to the left, it gives me a positive number. That's not normally the case when we think on a number line, but you have to remember this is not a number line. This is decimals that we're actually moving in direction, okay? So do not think about moving left or right like you would with a normal number line. Just remember this is counterintuitive, and if I move to the left, it's technically a positive exponent. So now that I've done that, this is technically going to be 1.14 times 10 to the 6th power. So if we wanted to make a rule, we'll say moving decimal left, add exponent. All right, by how many times you jumped or moved. Okay, so just a little mini rule right here just to kind of keep it in your head. And we kind of, like I said, we covered this in the last video. So the same concept happening here. This time I have 0.89 times 10 to the negative 6. So what do? I need to rewrite it. Well, this is pretty easy. I know I'm going to end up having 8.9 times 10 to the negative 6. And then I'm going to add or subtract something. So let's look at it. I needed to move my decimal one time. And notice that I moved it to the right this time, whereas before I moved it to the left. Well, since I've moved it to the right, I'm actually going to subtract 1. All right? And then when I do that and simplify it, I can say 8.9 times 10 to the negative 7. So the opposite is true if I move to the left. Moving decimal, not left, but right, subtract exponent by how many times you moved. So these are just two little side rules that we can try to remember to the best of our ability, because this is going to help us, especially when we go to add and subtract integers here in just, not integers, but scientific notation in just a minute. So what if I need to change a desired power? So this is the reason why I'm bringing all this up. So I need to go from 4.68 times 10 to the 5th, and I need to write it as a power of 10 to the 6th. So my issue that I have is this. I gained 1 if I'm moving it that way. That's telling me that if I gain 1, I technically moved my decimal to the left. So I'm moving it 1 time. And that gives me 0.0468 times 10 to the 6th power. Now, Mr. Lewis, you've told me that this is not scientific notation, and you're exactly right. This is not oops, put the decimal in the wrong spot. This is not scientific notation, but this is a very important skill, because as you will see here in just a minute, I cannot add and subtract scientific notation if they do not have the exact same exponent. So just to kind of go back to this, I was at 10 to the 5th power and I needed to change it to the 6th, which kind of means that when I have a positive number, I increased it by 1, so I had to move to the left by 1 decimal based upon this little rule that we defined. So the opposite is also going to be true. So I'm rewriting this here as 4.92 times 10 to the negative 3, and I want to rewrite it as 10 to the negative 5. So our little rule was that if I move a decimal right, I'm subtracting. So how did I go from negative 3 to negative 5? Well, I subtracted 2 because negative 3 minus 2 gives me negative 5. So that means I'm going to go to the right 2 times. So that would be 492 times 10 to the negative 5th. All right, so again, this is just something that you're going to have, there's no way of getting by this outside of memorizing this little fact. I cannot help that. This is part of math that really, really is a horrible, horrible thing. There's just some things you just can't help. So just to kind of remember, moving decimals left, add exponent by how many times you moved. Moving decimals to the right, subtract exponents by how many times you move. So it's just some very basic things. All right, so why do we even need to know this? Well, this comes to our first thing, adding and subtracting. It says my first step is to make sure the power of tens are the same. That is imperative, because if that's not the case, then you cannot add or subtract your scientific notations. Then it just says add or subtract the factors. Keep the power of 10 and rewrite in proper scientific notation if needed. So what did I just say? All right, so let's just go with some numbers and make some sense here. So look at this first one. I have 2 times 10 to the 4th plus 7.2 times 10 to the 4th. My first rule in adding and subtracting is making sure that the powers are the same. So this and this are the same. The second step is to says just add or subtract the factors. So my factor here is 2 and I'm adding 7.2. Well, 2 plus 7.2 happens to be 9.2. And then I just keep my power, which is 10 to the 4th. I'm done. That's all this one is. All right? Now, let's look at this one. I'm adding again, all right? But this time, notice that this exponent is negative 2, where this exponent is negative 3. So that means I have a problem. I need to rearrange one of these so that they both have the exact same scientific notation. Excuse me, not scientific notation, but we're changing it to having the same power. Sorry, I misspoke. So does it matter which one I move? Not really. So I'm going to move this one. So I need to change this to, say, times 10 to the negative 3. All right? So how did I go from negative 2 to negative 3? How did I do that? Well, I have to subtract 1. And according to our little rule that if we are subtracting, we're actually going to move our decimal to the right. So this right here will be moved 1 time. So this would be 32 times 10 to the negative 3 plus 9.4 times 10 to the negative 3. And now we can simply just add things like we normally would. So 32 plus 9.4 is going to give me 41.4. And then my powers were the same, so I can simply rewrite it. Now, here's the issue though. Notice that this is not in scientific notation, so I actually have to move it one more time. And in order for me to get it in scientific notation, I have to move to the left by 1. So that's going to be 4.14 times 10. And since I moved it to the left 1, that means I added 1 to your exponent. So this is to the negative 2 power. All right? I'm actually going to do 3 and 4 with you because I know this gets confusing, so we're going to keep working these together out. So, this one, I have 6.7 times 10 to the 6th power minus 4.3 times 10 to the 5th power. All right, so my job is to rearrange this so that they have the same power. So I'm going to just change this one to say something times 10 to the 5th. All right, so I'm going to change that one to 10 to the 5th. Now, in order for me to do that, it's actually subtracting 1. And remember, according to our rule, that if I'm subtracting 1, I'm moving a decimal to the right. Okay? So, when I do that, I'm going to move 1 time. So that gives me 67 times 10 to the 5th power. And I'm going to subtract that by 4.3 times 10 to the 5th power. Now it's just a matter of subtracting. So I'm going to have 10 to the 5th power because they're both the same. And I'm going to do a little scrap work over here on the side because I don't have my calculator. So 67 minus 4.3 cannot do that, so I need to borrow from here. This will be 6. This would make that a 10. So that's a 7. 6 minus 4 is 2. Don't forget your decimal. So that would be 62.7 times 10 to the 5th. But here's the problem. This is not in scientific notation, so we have to rewrite it. All right, so how do we do that? We're going to have to move our decimal to the left here. And because I moved it to the left, I need to add 1 here. So that becomes 6.27 times 10 to the 6th power. Now, you might be asking, well, how come I didn't change this to the 6th power? Well, I didn't. I just didn't want to. I could have put both of these at the 6th, and I wouldn't have had to simplify at the very end. It really doesn't matter. All right, so now we have an easy one. Notice right off the bat that this and this have the same exact power, so I can just write that down, and so that's cool. And now I have 8.9 times minus 1.9. Well, that's easy to do. That's just going to give me 7. Hey, I'm done. All right, so this is actually the hard part. So writing or adding and subtracting in scientific notations is actually the hard part. The easier one is actually when we multiply and divide. A whole lot easier to remember this. So if you look at the little rules that I gave you for multiplying and dividing, it says this. 1, you multiply and divide the factors, then you multiply and divide the powers, and then you rewrite to proper scientific notation. So that's pretty straightforward. There's no major issues on that. So I'm going to actually get me a little calculator right here so I don't have to work so hard. I hope you don't mind. Get my calculator on my computer. All right. So let's do this. I am multiplying these. So the first thing it says is to multiply the factors. Well, 6 times 4 gives me 24. Then I'm going to multiply my powers. Well, this is 10 to the 8th and 10 to the 6th. And recall when we multiply powers like this, what we actually do is we're going to add these two exponents. And 8 times 6 is going to give me 14. All right, so now my job is just simply this. I have to rewrite this in scientific notation. And so I have to move this decimal over by 1. And since I've moved it to the left, we need to remember we have to add 1 exponent. So if I moved it left 1, I add 1. So that changes us to 2.4 times 10 to the 15th power. All right, number 6. Same concept. I'm going to multiply the factors and I'm going to get 81. Then I'm going to multiply these two. So I would have 10 to the negative third times 10 to the negative third. And since they're multiplying, I'm going to add negative 3 and negative 3. And that gives me 10 to the negative 6th power. All right, but this is not in scientific notation, so I need to move my decimal to the left 1 time. And because of that little rule that I mentioned, we always add 1. Since I'm moving it left 1, I'm going to add 1 because it's counterintuitive. So that gives me 8.1 times 10, and negative 6 plus 1 gives me negative 5. 7 is division. Same concept. We're going to divide the factors. 8 divided by 2 is 4. And then we're going to divide 10 to the 3rd power, divide by 10 squared. Since I'm dividing, that means I'm going to subtract these exponents. Well, 3 minus 2 gives me 1. All right? So this is in scientific notation, and I'm done. Let's do the next one. All right, I have 2.34 times 10 to the 5th divided by 7.8 times 10 to the 5th. All right, well, I'm going to go ahead and divide here. 2.34, I'm going to use my calculator here, 2.34, and I'm going to divide by 7.8, and I get 0.3. Well, that was not as bad as I thought. All right, and then I have 10 to the 5th being divided by 10 to the 5th. Well, since they're being divided, that means I'm actually going to subtract my exponents, and I'm going to get 10 to the 0 power. All right? Now, right now, if you look at this, we can actually do this a couple of ways, but we need to remember that we're writing in scientific notation. So let's keep that pattern first, and then I'm going to show you another way to do this, write this as another answer. So because this is asking for me to write this in scientific notation, I need to move this decimal to the right, okay? And when I do, that changes it to 3 times 10, and since I moved it to the right one time, I actually subtracted 1. So what this answer is 3 times 10 to the negative 1. Now, if you look at it, this is what the answer is in scientific notation, but I did want to show this to you. I'm going to show it off to the side. This is not the correct answer because it's asking for scientific notation, but I do want to show it to you. What's 10 to the 0 power? 1. So technically, if we were writing in standard form, the answer to this would have been 0.3, because 0.3 times 1 would be 0.3. All right, so that's it for this one. I'm going to leave 9 to you. And this one, please take your time with it, especially when you're doing the sum and differences. That is probably very complicated to remember the little steps here of going back and forth between your scientific notations and making sure that you have your exponents lined up. That's tedious. Just be very careful with it. You know how to find me, and I'll see you in the next video. Bye-bye.